What we're going to be doing, and again, you need a graphing calculator. Everybody has one here? You can't share. I want you to practice with your own. Okay? We're going to be looking at applications. And Jordan, they're going to seem very scary at first because they're word E problems. They're going to give you the equation, though, in the word problem. And I'm telling you, it's either going to have a variable up top, an exponent, or it's going to have the word log in it. Then, Rachel, what you're going to have to do is read what each variable means. Those of you that are in physics will have learned the trick of looking for units and things like that. So it says this. In this lesson, we're going to use graphing techniques to interpret graphs of exponential and logarithmic functions. There are many applications of exponential and log graphs in real life. Some of them are cool. A lot of them involve radioactivity and things like that. Remember, an exponential function looks like that. Now, the examples, Brianna, that we're going to be looking at aren't going to have an x and a y. They're going to have specific variables for the situation that we're looking at. We can use variations of this to solve population questions, bacteria questions, radioactive decay questions. Recall, a growth function looks like this. A decay function looks like that. Oh, a decay function, your base is a fraction. A growth function, your base is bigger than 1. And then a log equation has the word log in it. And Rachel, there are lots of applications of logarithms. Richter scale is actually a logarithmic scale. pH levels, and you do them in chemistry, some of you as well. Decibels, sound levels, all sorts of stuff. Okay. Ashley, it's easier just to jump into a question. So here's the kind of things you're going to be doing in the homework. They're going to be using lots of words. Don't freak out. Logan, it says this. In 2012, check. University population of a country was 160,000 and was increasing at an annual rate of 4.5%. It can be described by that equation, this one. By the way, can you see where that 160,000 initial population appears in the equation? See it? Generally, if we were doing this, we would say, oh, your initial population goes where A is. A is where things start. What was the rate of increase, Darian? What percent are we increasing by? Can you see the 4.5% that sort of appeared in the equation? But what else is it? It's not a 0.045. What is it actually? 1 is 100%. The original population plus the increase. That's what that's from. If you're increasing by 8%, there's going to be a 1.08 inside the brackets. That's your base. If you're increasing by 12%, there's going to be a 1.12. If you're decreasing by 12%, there's going to be a 1 minus 0.12. There's going to be a 0.88 to the n. All right. What does the letter P stand for according to this question, Zach? So whenever they talk population, I'm going to think Y variable, because this is very similar to that. And the problem is our calculator can only handle X's and Y's, so we're going to be typing these into our calculators with X's and Y's, but our brains are going to have to superimpose P for population. Oh, and what does the N stand for?
Number of years.
Number of years. Okay? That's important. That means if they give me a number and it's a population, I'm putting that in for the Y value. If they give me a number and it's a time, I'm putting that in for the N value. Okay? It says, if this function is a disguised version, what's A and what's B? If this here is meant to match that, which it does. How do I know? Because there's an exponent as a variable. What's sitting where the letter A is? Don't overcomplicate it. What number is sitting right there over here? 160,000. What number is sitting where the base is? 1.045. And Darien, in the old Math 12 curriculum, we actually made the kids come up with the equations on their own, and my students would memorize whatever my initial starting point, if it's a popular, whatever I'm starting with, that goes where the A goes. It was kind of nice, because what's the first letter of the alphabet? That's your starting point. At least that works nice. And then whatever my rate was, that went where the B is. If it was the percentage, you had to add 1, though. So it's not 0.045, it's 1.045. Says, use a graphing calculator to graph a function which will show the population growth from 2012 to 2040. State an appropriate window. Okay. Now, what letter, Hannah, is right there as an exponent? X. What letter is right here as an exponent? N. So on my calculator, when I think X, I'm thinking how many years? I'm going to start with year 0 from 2012 to 2040. How many years? Please do the arithmetic, either in your head or on your calculator. How many years? $30? Okay, exactly 28. But you know what? I like Mackenzie's suggestion. Let's go a bit past it. Let's say that you were being clever and said, you know what? Let's go, our X min is going to be 30 on our window. So our X min is going to be 0, starting point. Our X max is going to be 30. Now, on my graph, before you start changing stuff, remember your screen is only about this big? Going from 0 to 30 in that big a distance, a scale of 1 would be terrible because the hash marks would all blur together. What would be a nice scale to go up by between 0 and 30? There's not a right or wrong answer. This is just going to be 5 would be, you know what? So I'm going to have, this is how you write a view window. The first bracket is your X values. So if you can get out your graphing calculators, go to your graph menu, delete any graphs that are there, and then remember, don't hit F3, that changes the type of graph and you get into all sorts of hot water. Hit Shift F3, my minimum X is going to be 0, my maximum X is going to be 30, scale 5, and now I'm going to pause. Do you see, Oscar, how I was just kind of able to reason my way there? I had to figure out, okay, what's X in my actual equation? N. What does N refer to? Number of years. Oh, they said from 2012 to 2040, 28 years. Mackenzie cleverly said, go to 30. Nice round number. Take credit when, fake it, right? Now, the Y values, that's the population. The Y value, that's the population. Well, I'm going to start at 0. I almost always start at 0, 0. How big am I going to get? I don't know. I don't know yet. So I'm going to leave a space and then a space for the scale. I'll come back to it. But what's my initial population? By the way, for Y min, put a 0. What is my initial starting population according to this question? So my Y max has to be bigger than that. How big do you think, rough guess, will be in 30 years? What would be a good guess? 1 trillion would be a bad guess. 161,000 would also be a bad guess. I think you're going to go up by more than 1,000. Julia, best guess. How big do you think the population is going to be? There's not a right or wrong answer. This is how we do it. Okay, I'm going to try 350,000 as my Y max. We might be too high, in which case we'll just go adjust. How will we know if we're too high? We'll notice that our graph only takes like the bottom third of our screen. We have way too much. Or we might be too low. How will we know if we're too low? The graph shoots off the screen before we get to the end. Okay, so I'm going to show you both versions. Supposing, Julia, you said 170,000, which is too low. You could tell, because when I hit draw, oh, I got to type it. Sorry, we got to type in our equation. Duh. Let's type in this, except instead of an N on my graphing calculator, what letter will I put there? I heard it. What? X. Okay. Oh, and wherever I see a Y, what's that really going to be? P population. So I'm going to go 160,000 times 1.4045 to the power of X. Now, if I hit draw, 170,000 is way too small. See it? Barely fits on. What was, Julia, what was your suggestion? Okay, so let's try that. Now, if we go from 0 to 350,000, what would be a good scale? Ones would be dumb, because that would be trying to fit 350,000 hash marks in that big. What would be a good scale? You know what? I think every 50,000. Okay? Oh, 500,000. Does that fit? Nope. Not quite. You need to go higher. Okay, Brianna, go higher. What should I try instead of 350,000? There's a guess. It's not a I don't know. This was too low. Give me another number higher than that we might try. A nice round number. Try 500,000. Let's try 500,000. Ah! Still sneaking off a bit there, isn't it? Try what? 600,000? See what we're doing? We're guessing here. We're trying to get this all to fit on our screen. Oops, hit the wrong button. 600,000. Does that fit? Yeah, barely, but sure, that works. Okay, so I'm going to write for my view window. I started at 0. There's my view windows, Hannah, always go min, max, scale, min, max, scale, and you always do the X first and then the Y. What was our scale? What did we go up by for the Y values? 50,000. Okay. And I guess I don't need a comma right there. This is a graph of population growth. Now we can use our graphing calculator to analyze data. Okay? What does C part 1 want me to find? Stop. Brendan, what? Stop. Brendan, what? You're right. Say it again. I'm going to change that. Does it want me to find an X value or a Y value? Look at my original equation. Population, is that sitting where the letter Y or where the letter X is? You see what I'm getting at? So here's my original equation. Which variable is population, the letter P or the letter N? How do you know? Because it says where P represents the... This is why I said, don't freak out. You got to look at the words. Okay, so you ready? Brendan, I'm going to ask you the same question, but I'm going to phrase it differently. Does this question want me to find an X value or a Y value? Say it loud and proud.
Y value.
Why? Because population is the Y value. Is that okay? Everybody see how we figured that out, Emmerich? Yeah? Okay. I'm going to phrase that slightly differently. What we want to do is do a Y calculation. A Y calculation. You ready? Look up. G-solve, where all the fancy graphing stuff is. F5. Brendan, what did you say we wanted to find? Which is a Y calculation. Find that menu. Not here. Oh. A Y calculation. Which is F1, yes, after you hit F6. And it says enter, it says enter the X value. Okay. What letter is sitting where the X is? N, which stands for what according to this question? Number of years since 2012. So Brendan, if we're in 2015, what X value am I going to enter? I caught you zoning out. Ready? What is the X? What letter is sitting where the X is? N, where N stands for what? Look up. Since? So what's my X value going to be here? Not 2015. The population in 2015, do this on your calculator so you know how to do this, is going to be approximately what? 182,000. Why wouldn't you say 586.6? Why wouldn't that make sense in this question?
There's no such thing as less than a full person.
Yeah, we're talking people. Okay? Sometimes decimals are okay. Well, I know someone who's really short. No, we're not talking about that. Okay, so 182,580, 182. Carson, is that okay? G solve, F5. By the way, please don't use a pencil to hit the buttons. It wears the paint off these buttons far faster than your fingers. Okay. Y calculation, is it on the first screen? Then arrow sideways. Should be F1 on the second screen, yeah? Once you hit G solve. Okay, let me pause. Oh, you get it okay? Yeah, okay. By the way, for all of these, Sterling, you're either going to be given an X value and you want to do a Y calculation, or you're going to be given a Y value and you want to do an X calculation, except they won't ever say X and Y. They'll use the variables from the equations, and you have to figure out which one's which by looking at the equation. So, Grayson, my joy. Part 2, what's it asking me to find? Read to me the first phrase. Stop. What? Stop. What? Okay, I'm going to ask you the same question. Is it asking me to find a Y value or an X value? Jake, you said X. How do you know? Look at the equation up there. Which is the number of years? The letter P, Grayson, or the letter N? And is the N sitting, because here's our template, is the N sitting where the X normally does or where the Y normally does? So, is it asking you to find an X value or a Y value? I'm going to phrase that just slightly differently. Is it asking you to do an X cal or a Y cal? Say this X. So you ready? G solve. I don't see X cal yet. Arrow sideways. Oh! It's going to be G solve, arrow sideways, which F6, right? And then F2. And it says, enter a Y value. Now, Grayson, I need to think, what Y value did this question give me? And here is the Y value. What word did I underline? Double from the original. What was the original population? 100 and... No, that's in 2015. What was the original population? 160,000. Double that. I think it's reasonable for me to ask you to double that in your head. 320,000, right? Okay, that is going to be the Y value. When will this population double? After how many years?
15.
Between year 15 and year 16. You know what? Since it says the number of years required to the nearest year, it's going to take 16 years. See how we got that okay? Yeah? Okay, hang on. Yeah. Okay, then you need to get your hands up sooner, please. Let me pause here. For those of you that we've got this graph going, got the graph? So right now, can you do me a favor? Can you find the population in 2020? Now, how am I going to do that? What am I asking you to find here? What am I asking you to find here? Population. In the equation, in this equation, is population sitting where the letter X is or where the letter Y is? Because I asked you to. Is population sitting where the letter X is or letter Y is? Y. Because I asked you, I'll never get tired of that joke. Okay, it's a Y value. So this is asking us to do a Y calculation. Okay? You okay with that? Bree, you okay with how we figured that out? Now, what's N? What year are we in, Brianna, according to this question? Now, N is measured from the year 2012. So how many years have we gone from 2012? 8. So what I would do to answer this question, I would graph it. I would go G-solve, arrow sideways. I want a Y calculation. When X is 8, we would assume that in 2020, the population is going to be 227,536. Can all of you do that, please? You need to know how your calculators work. And the fact that I was showing some of you where exponent buttons and X's were suggests some of you haven't done the homework. And it's going to hit the road soon. I only got a couple more lessons and then your test. And I'm not going to help you figure your calculators out on the test. So can you get that? Okay, you ready? So you need to follow along with me. You can't be... Here we go. G-solve. Hit that, which is F5. I want to do a Y calculation. Do you see Y calculation here anywhere? So arrow sideways, which is F6. Oh, F1 is a Y calculation. It wants the X value. Brianna, you told us the X value in this question was 8. And it gives you the Y value. Okay? Or I can say, when will we hit 300,000? 300,000. There we go. What's this question asking me to find? An X value or a Y value? This is asking me to find an X value. How do I know? What's that 300,000? Population, P. They're giving me a Y value. They want me to... And every question in the homework, they're going to give you an equation. And you're either going to find an X value, they're going to give you the Y value, or you're going to find a Y value, they're going to give you the X value. But you need to be able to figure out which one's which. So here, you guys can follow along. It's still going to be G-solve. It's still going to be arrow sideways, but this time we want to calculate an X calculation. What's the Y value? That. Apparently, after 14.3 years, which from 2012 would be whatever, I'd have 2012 plus 14. Is that okay? Did I do 30,000? I did 300,000. Yeah, I'm right. Is that okay, Hannah? Yeah? Now, back to our notes. Let's actually answer this question. So we said doubling, G-solve, arrow sideways, X calculation. Doubling was 320,000. And we said that's going to happen after 15.7 years in... What year are we in? Wait a minute. It said to the nearest year after 16 years. If we're starting in 2012, what year are we now going to be in? 2028. Is that okay, Rach? Yeah? Is that okay, Jordan? Let's try another one. Next page. Excuse me. Says this: the number of fish in a lake is decreasing. Let's underline the word decreasing. The fact that we're decreasing, Chelsea, we're going to get a graph that looks like that. One of those ones. I can draw that a little better. We're going to get a graph that looks like that. Each year is the result of overfishing. Here's the equation. Right there. Is this an exponential equation or a logarithmic equation? Carson. You see the word log in there? This is, how do you know? Look where the t, the variable, is sitting. Okay? This looks just like that. It's just got different stuff. But I'm telling you, there's a variable as an exponent, and on the left-hand side, there's another variable sitting where the y is. So what type of function? What does the letter T stand for according to this question? Read the question, please. Years. Whenever I see a number with years next to it, that's going here, where the T is on my calculator, where the X will be. It's going to be, okay? What does N stand for, capital N, according to this question? Read the question. Population. What does this N0 stand for? Initial, which they haven't told. Oh, wait a minute. They just told me the initial right here. In June of 2012, there was 2,500. So, as an equation, initial population, 0.95 to the T. Is that okay, Mac? Hey, by the way, where'd the 0.95 come from? That's a decrease of 5% from the original 100%. So you always start out with your original population, which as a number is 100%, which as a decimal is 1. All right. It says, use a graphing calculator to determine how many fish will be present in June 2017. Okay. We need to pick a good view window. Here's my X values. Here's my Y values. X min, X max, scale. Y min, Y max, scale. Very carefully, hitting Shift F3 without accidentally hitting F3 and changing what kind of a graph you're in. Hitting Shift F3. Go to your view window menu. I always start with 0. What's sitting where the X variable is in this equation? A letter T. See it? What does T stand for? Years. How many years do we want to cover in this question? Giancarlo. You're right. 5, because it says 2012 is what we started, 2017. I always I'm going to go a bit past. I'll say 7. Okay? Because, by the way, the reason I always go a bit past is if it's right on the edge of my screen, it might get cut off. 8 would be fine, 10 would be fine. This is not a right or wrong answer. There's just better or less effective. Okay? Scale, you know what? From 0 to 7, I think I can go up by 1s. Why? Oh, so let's fill that in. 0, 7, 1. 0, 8, 1 I would take as well. It's just our graphs would look different. Y min, I always start with 0. How big are we going to get? What's my starting population? 2,500. Are we increasing or decreasing? You know what? Since we're decreasing, the highest this is going to get is 2,500. So 0. The only problem with going up to 2,500, that's going to be right at the top of the screen. It might get chopped off a bit. I'm going to go, what's a nice number, slightly or a little bit bigger than 2,500, nice round number? 3,000, sure. What would be a good scale to go up by from 0 to 3,000 so that you could kind of read stuff? 500? Sure. So 0, 3,000, 500. I've got my view window. And again, if you're asking, Mr. Dueck, how did you get that answer? These are not answers. There's not a right answer. There are wrong view windows. What's a wrong view window? If your graph gets cut off by the edge of the screen or by the top of the screen. Then you picked a bad window. Now, Brianna, everybody got that? I'll pause this time. Now, hit exit, delete this equation, and type in the new equation, 2,500 times 0.95 to the power of x. Again, that's a times, that's an x, and then hit execute to store it. Ideally, Zach, you should get a decay graph. Hit draw and see if you get a decay graph. Should look, there you go. Mr. Dueck, I don't see the bottom of the graph. Well, we didn't go far enough years into the future. This question didn't require us to. Okay. Have we got our setup? We haven't answered the question yet. Giancarlo, what did this question want me to find in part II? Number of fish. I'm going to ask you the same question, but I'm going to phrase it differently. Does this question want me to do a y-cal or an x-cal? Number of fish is x? How do you know? N, number of fish sitting where the y is. So this wants me to do a y-cal. So everybody, G-solve. Navigate to y-cal. That must mean there's an x value. How many years are we talking about? I'm covering it up with my calculator, but I think you guys have it in front of you. What year do they want us to figure this out for? 20 what? Oh, so how many, what's T? Because it says start from 2012 again? Okay, 5. How many fish will there be in 5 years? $1,934. Yeah, the black ones are a little slower. And especially they really go slow if you're doing an X calculation. Yeah, you can see it moving along, yeah. Everybody got that okay? You know what? This is a guess, but I'll bet you since we just found a Y value, I'll bet you the next one is going to ask me to find an X value. Yes? Okay, pause. Hey, let's look at part C. Logan, what are they asking me to find in part C? How many what? Okay, I'm going to ask you the same question. Years, are they asking me to do a Y calculation or an X calculation? Go look at the original equation. Where is time years sitting? Where the Y is or where the X is? Okay, I'm going to do an X cal. By the way, up here they wanted us to write how we did it. You can make a little note. We did a Y cal, and we're going to do an X cal. Can you keep reading part C to me, Logan? How many years to the nearest tenth? Okay, to half. That's the Y value they want me to enter. What Y value am I going to enter? So I'm going to go F5, arrow sideways, X calculation. What did we start out with? How many fish? 2,500. So what would half of that be? When will we only have half the fish left? Uh-oh. Did you guys get that error as well? Okay, here's what that means. It's off the screen. It's off the screen. It doesn't happen in the first 7 years. You know what we need to do? Change our view window. It says press exit. I'm going to go carefully shift F3. How many years? Let's try 10. That was what somebody suggested. Draw, G-solve, arrow sideways. 1250. Nope, not found. 20 years? And you're going to, by the way, there is no easy intuitive way. You're going to jump around a little bit and you're guessing. So 20, does it?
It works in 20.
15 works, 20 works. And since all they want is the number, I don't care if, Julia, your graph looks different from my graph. In fact, really, if I wanted to make sure I got it, I could have just said, well, I'm going to go 50 years. Even though my graph is going to look weird, it's going to give me the answer. I could have done that. G-solve, arrow sideways, X calculation, 1250. And I get, oh, after 13, is it 13 and a half years?
Yeah, but to the nearest 10 should be 14.
No, to the nearest 10th will be 13.5. Is that, anybody not get that? Your graph might look different from mine because I went 50 years into the future. Everybody there? So, 13.5 years. What year will that be? Oh, they only wanted in how many years? But for what it's worth, I could tell you what year that'll be. That'll be in 2025. Plus a half year. You know what? Since June is halfway through the year, this would actually probably kick over right around 2026, right around December, January. But I'm going to go in 2025.5-ish, whatever. Let me say this again. In your homework, they're going to give you an exponential function or a logarithmic function. You're going to have to kind of figure out what view windows work by just looking at your graph. Doesn't fit. Well, then get wider. Oh, it's way too big. Then get smaller. And every time, Alyssa, they're either going to give you a y value and say find an x value, or they're going to give you an x value and say find a y value. Alyssa, example 3. Are we doing a log graph or an exponential graph? And how can you tell? Why? Captain Obvious. How come? Log. Okay? Now this is terrifying looking, but wait a minute. Whenever I see pH, I think I'll put that for the x value or y value. Look at the equation. Whenever I see pH, I'll put that in for the x value or the y value. Which one? The y. And whenever I see H+, which apparently stands for hydrogen ion concentration, I'll put that in for the x value. I don't know anything about chemistry, but I can read units. When I see moles per liter, that goes where the x. If I see pH, that goes where the y. Oh, this one is nice. They gave me the window. See it in part A? See how they wrote it? The same way we've been writing it. Square brackets, x min, x max scale, y min, y max scale. So I'm going to delete this equation, or you could delete it later, but I'm going to change my view window to what they gave me here. 10 to the power of -6, which is really small. 10 to the power of -3, scale 1. 3, 7, scale 1. Is that okay? You guys are missing this. Zach, they gave me the view window right there. I'm just copying it right from there. Square brackets is view window. 10, exponent button, -3. The exponent button's not working, then you're in something wonky. Hang on. It says graph this. Okay, so here is my equation, except that's going to be a y and that's going to be an x. So you ready? Go back to this screen here. I don't need to type the y. It's already got the y. There's going to be a negative. Look up. Make sure you use a negative and not a subtraction sign. Negative log. I don't know if I need to put it in brackets or not, but I will since they did. Log x. And then hit draw. And hopefully we get a nice... Oh! It went fast? Really? Really? Because logarithmic calculations are... Okay. Anyways. It says sketch the graph. It looks sort of like a decay graph, but it came out of a logarithmic graph. Anybody not get that? Rachel, what does B want me to find? Stop. Go look at the original equation up there, and I'm going to ask you the same question. Guys, I need you to stop talking. I'm going to ask you the same question, but I'm going to phrase it differently. Does part B want me to find a y value or an x value? What does B, read me the question. What does B want me to find? The what? The what? Go look at the original equation. Is pH sitting where the y is, or is pH sitting where the x is? So this wants me to do a y calculation. I told you. It's going to do one or the other. Okay? So, wrong button. Graph. G-solve. Y calculation. What's the x calculation? Now, everyone look up. Those of you that are in physics are okay with scientific notation. Black calculators, we're going to see if this works on the old ones. Here's how we type in 3.4 times 10 to the negative 4. Can you all look up, please? Everybody's going to go 3.4. And then the symbol for scientific notation, the abbreviation for scientific notation. Let me pause. Brianna, question? Are you here? We're doing a y calculation. So you need to help her navigate there. Okay? Are we there okay or not? Yep. Okay. So give it back to her once we're there. 3.4. This EXP button on the bottom, that's the abbreviation for times 10 to the power of. And it symbolizes it with a little e. Did it let you hit that in the black calculators? Ah, okay. And then the exponent, negative 4. That's 3.4 times 10 to the negative 4. Hit enter. Now, I have no idea about molar mass and hydrogen concentrations, but apparently the pH is going to be, it's going to be what? 3.5. Sorry, not 3.4, 3.5. By the way, who remembers from their Science 10 or their chemistry, does that mean it's acidic or alkaline? What does water have as its pH? Because water is neutral. 7. So is this less than 7 or more than 7? Less than. This is acid. This is very acid. Alkaline is bigger than 7. Acid is less than 7. Milk? No, milk is around 9. 14 would be really high. That would be a cleaning product that would probably melt rubber gloves.
It would be ammonia.
I don't think ammonia is at 14. No, it would be something toxic enough that you probably need certification or a license to use as a cleaning product. It wouldn't be something you could buy over the counter.
You're talking about basic concept, right?
Yeah. We can get to that, but I want to get through this, and I love the nerd conversation. Hey, Rachel, we just found a y value. I'll bet you for part C, they're going to ask us to find an x value. Just thinking. Let's see. Oh, this here is what? A pH. They've given me a y value. What do they want me to find? An x value. They want me to do an x cal. Good, do an x cal and tell me what x value, what hydrogen ion concentration would result in a pH of 5.7. Almost exactly 2 times 10 to the negative 6. That's what that little thing there means. E negative 6. or 0.00002. What are the units for hydrogen ion concentration? Moles per liter. By the way, I got that right from the question, right? In brackets, it says expressed in moles per liter. I'm going to give you some to try right now. I'm going to pick up with this next class. So which questions can you try right now? Number 1, pick a good window. By the way, look at number 1. Are we losing money or gaining money? How can you tell? Also because that's less than 1. Even if you hadn't told me depreciates, if I just saw the equation, which means that 28,000 is the maximum. If you're doing your view window, Y max should be 30,000, let's say. Number 2, here we're increasing. We're starting at 50,000. You'll have to kind of guess your way to what your Y max is. It'll take you a couple of graphs to figure it out. I skipped 3 and 4. Number 5. You can try number 6. I'll pause right there. We're going to do a bunch more of these, though, next class and continue on.